Hi everyone, so today we're going to go through workshop 3 and I'll start with question 3.1. So question 3.1 is fairly straightforward. Essentially we just have to write this bstInsert function and this freeTree function. There's kind of a clearer, a solution that matches very closely with the algorithm that you might have seen, but then there's another where essentially you do a recursion down the tree until you find where you need to go, then return back up the tree doing assignments. What I'll run through this time is a different algorithm, the iterative approach, which essentially instead of recalling bstInsert, we just we kind of do one step where we find where we want to put it, and then the next step is essentially just taking that and putting it in actually putting the value in there. Alright, so the start of this function is we can take a look at main, and essentially it scans in some data from here, and for each of those it inserts those, that particular number that it gets, and this bst starts as null. So if we take a look at bstInsert, we see that essentially we start with this null when we've got nothing there, and this is the data we want to insert. So relatively clear so far, I think. So the first thing that so the kind of process we'll be going through for this one will be essentially to move down the tree. So we start pointing to here, and then if it's less than, we go down this one, greater than or equal to, we go down this one, and we essentially just look for like where to actually put it. So we might find that it's greater than this one, and then less than this one, and then greater than or equal to this one, and so on. And then when we finally get to something that's empty, then we might go, we actually allocate something there and set its values. Alright, so let's actually do that. Alright, so first of all, we need something to point to where we want to put it. And first of all, we'll make that the actual parent node. So this is, for example, if this parent was a null pointer, then we want to fill in that value. Okay, so now we'll just have a while loop. So while we haven't reached one of the leaf nodes, so while we're not here, then we're just going to keep going down. So while that insert location is not null, well, rather the value at that location is not null, we're going to traverse down. So if the data is less than the value there, oops, sorry, data. So the data at that location, then we're going to move down the left side. So insert location equals the address of that insert location left. and then otherwise we'll do right. Oops. And then that's our while loop. So now we're at a point where there's where insert location points at the location that we want to put it in, which may be the parent, for example. Okay, so that's that part. Now we know this is a null pointer, so we'll allocate, we'll allocate space for it. So that'll be a struct bst pointer, and we need space for a struct bst node, and then we have to actually check that malloc didn't fail. So we check that that's not equal to 0, and that should be fine. Yeah. Alright. So now we just set the other values. So insert location left equals null, right equals null, and the data is the data we wanted to actually put in. And then we want to return this parent that we originally had, and we might have updated that or not, but we'll return that parent. Okay, so that's how that works, the iterative approach. The other thing that we have to do, so if we run this and flash standard out, we see that that prints out and is correct, but we also get these errors, and something that kind of helps with these kinds of errors is to turn on the line numbers, which you can do. Alright, so that's actually something we like. The reason why it's good to free memory as well is because you know whether you lost stuff you didn't mean to actually lose. So in this case we want to free the tree, and we're just going to do a fairly simple process. So if we've got a bunch of trees, like a tree, and this is our root here, we're going to basically go all the way down here and then free this one, then back up here to free this one, and then all of this one's children are free, so we can free that, and then repeat that process for this one, then we can free this one, then we repeat the process for this one, then we can free this one, and we've freed the whole tree. So that's kind of our logic. So here we do a freeTree parent left, a freeTree parent right, and a free parent, because we actually want to free things, free the tree. Right, so let's get rid of that flush, and now we see that. I'll try that again. Okay, so that prints out fine. Yep, cool. Not sure why that didn't work before. Oh, there it is. Cool. So that's that problem done.